Good morning, my audience. This is a continuation of the computation of Lyapunov exponent using Python. Now, I want to compute this exponent using ODE, which is also a deterministic system. To get the code, I will give this instruction to ChatGPT in order to get the code. The instruction reads, give me the Python code to estimate Lyapunov exponent based on deterministic dynamical system using ordinary differential equation. My data are saved in my desktop using CSV. Username is Dell. File name is market_data and variable name is price. So I copy it. Then I move it to chat to execute. Once I put it in chat, then chat will give me the code. This is the code, and then I will go to Python to execute that code. Python to execute the code. I paste, then shift enter. Yes, this is the results based on ODE, deterministic Lyapunov exponent via fitted ODE. And then the exponent is linear deterministic, and the exponent is 0.0010. Having gotten this, I can move to the next one, which is a deterministic also, because like I said, using AMA, the stochastic part is terminated. So if the stochastic part is terminated, then what we have is deterministic. Then I can also give this instruction to Python to chat in order to get the code to be executed in Python. Now the instruction X, give me the Python code to estimate Lyapunov exponent based on deterministic dynamical system using AMA model. My data are saved. My data are saved, not saved. Please let that be corrected. My data are saved in my desktop using CSV. Username is Dell. File name is market1_data and variable name is price. So let me Control C. I will go to charts to get the code. Control V, enter. Yes, now I have the code. This is the code. I can copy and execute. This is the command. Copy, then to Python, Control V, Shift enter. So look at the results. I have that the Lyapunov is positive 0.0012 and is based on AMA, Lyapunov exponent from the deterministic AMA model. Now, having done all this, the next one is to compute the Lyapunov exponents Lyapunov exponent using the algorithm of using rolling window. We have to compute the Lyapunov exponent based on rolling window. Now the instruction for that is to be copied and pasted on ChatGPT in order to get the code. Now what is the instruction? Give me the Python code to estimate the Lyapunov exponent based on stochastic dynamic system on rolling window. My data are saved in my desktop using CSV. Username is there. File name is market1_data and variable name is price. So I copy this also. Then quickly I take it to charts. Now put it charts. Then Ctrl V, enter. So, just enter, not Ctrl V, enter, because that is chart. In chart, you just enter, not Ctrl V, enter. Now, once you enter, it will give us the code to estimate the Lyapunov exponent based on rolling window. I think the method here is Rosenstein algorithm. Now let me see what I have. So this is what I have. I'll copy this. And then I will just paste it here, shift, enter. Yes, this is what I have. Like I told you, like I said, this is a rolling window, but this is stochastic dynamic method on rolling window. Then I can, let's see the windows. We have 500, 1000, 1500, 2000, and so on and so forth. Now we can move again and say that we need it on, let me see the next thing we have. So we need it on GBM, SDE GBM, that is geometric Brownian motion. So I will simply go and instruct. I need the code. I need the code for SDE geometric Brownian motion method. I need the code for geometric Brownian motion method for the rolling windows. Then I'll enter. Okay, now this is what we have. Let's see the code. So this is the code. We copy likewise. We copy the code. Then execute. Ctrl V. Shift, enter. So this is my results. Now, interpretation of all these results. Interpretation, where you see the lambda, if the lambda is greater than 0, that means positive. That means that there is limited prediction. There is limited prediction. Alternatively, we have short-term prediction, or short-term prediction is feasible, but long-term range prediction is impossible. This implies that the market is inefficient in the short range, and there is existence of independence in the long range. The long range you can't predict, but in the short range you can predict. That is when Lyapunov's coefficient is positive or greater than 0. If the Lyapunov coefficient is approximately 0, that means that there is existence of randomness or stochasticity. In that wise, the market is efficient in the weak form. You can't make any prediction, either in the short range or in the long range. So therefore, the market is assumed to be efficient in the weak form. If the Lyapunov coefficient is less than 0, negative, that means that there is existence of mean reversibility. The market is inefficient. Prediction is possible. Prediction is visible. You can make your prediction. So the implication of all this in the Nigerian stock market, which we have made our trend on, or which our trend is based on, anywhere you see the Lyapunov exponent negative, it means that the market is mean reversible. It can be predicted, and therefore it is inefficient. Where you see the Lyapunov coefficient greater than 0 positive, that means there is short range possibility of prediction, and the market still yet is not efficient. Thank you very much once again. My name is Ajibola Rewa. I hold a PhD in finance. I specialize in asset pricing, financial econometrics, and financial modeling. Thank you.